We are still working on solving systems of equations. So we were able to solve systems of equations by graphing, by looking at that point of intersection. And so both lines went through this point 1, -2. So that is the solution. X is 1, Y is -2, and that is where they intersect. It's where they're the same. So on slide 14, we're identifying solutions from a table now. So finding the solution of a system from a table, remember the point will show up on both tables if it's a solution. Some values for two linear equations are shown in the tables. What is the solution to the system of equations represented by these tables? So I'm going to zoom in so we can look at it. We're going to use our scribble tool to find our solution. So this is like the first equation. This one's the second. So we need to find the solution. So that would be where the X and Y are the exact same on both tables. So grab your scribble tool. And let's see, where are they the same? -2, no. 5, no. 8, 6. Oh, and this one has 8, 6 also. So that is the solution. Good. So I'm going to circle it on both tables. So wherever the X and Y are the exact same on both tables, that is the solution to the equations. We don't even know what the equations are. We could find them because we've learned how to do that, but we don't have to. All we're asked to find is the solution. So the solution is 8, 6. So make a text box and put the point 8, 6 in it. All right, let's look at the next one. You're looking at your X and Y's and seeing where they match up. Looks like 0, 6. Is where they match up. So 0, 6 is our point of intersection. So type that in a text box. Okay, let's keep on going. We just have a couple more examples. Let's look here. This looks just like the table on our calculator where we have X's and then we have Y1, Y2. So we're looking at where the Y1 and Y2 would be the exact same. So it looks like it is -4, -2. Look at the next one. X is 0, Y1 and Y2 are both 7. X is 3, Y1 and Y2 are both 5. X is 6, Y1 and Y2 are both 3. So what does that mean about y1 and y2? Parallel would mean they never intersect. Do these?
They're the same equation.
It's the exact same equation. So what is it? Infinitely many solutions. Yep. Good job. Same exact equation. Okay, the last one, 0, -3, -3. 3, -3, 0. 6, -3, 3. Do y'all see the solution? 0, -3. So finding from the solution from a table isn't too difficult. You're just looking for the match. Or y1 is the same on, or y is the same on the x, same exact point. Okay, let's look at slide 15. This is all about estimating systems graphically. So you will be given a set of information, so a system of equations, maybe a word problem, and then asked to determine what the solution is to that system. So we're going to look at the first one. The system of equations a plus c equals 950, and then 6a plus 4c equals 4,840 can be used to determine the number of adult tickets A and the number of children tickets C to a zoo. Use the graph below to estimate the number of adult tickets sold. So let's talk about what these equations mean, because you are going to be asked to write equations today. So we've got to know where these equations are even coming from as part of the word problem. So it says the number of adult tickets A and children tickets C. So the first equation says A plus C equals 950. So I'm going to replace these with words. The number of adult tickets plus the number of children tickets equals 950. Then 6A plus 4C equals 4,840. What do you think that represents? The cost, yeah. So it's $6 per adult ticket plus $4 per children's ticket equals 4,840. So they've already graphed this for us. So it looks like they put A as the x-axis and C as the y-axis. So we need to find the point of intersection. So I'm going to zoom in so I can find the point of intersection. That would be my solution. So I'm going to do a circle. Looks like it's right around there. I'm going to make it red. So make your point on there. So now we need to estimate. What are we estimating? the number of adult tickets sold. So we want to go on the A or the x-axis and follow it up, or follow, yeah. Where would it be?
525.
Maybe 525-ish? Okay, so what are our answer choices?
425, 800, 520, about 25 adult tickets.
Okay, so 525 is right on the money.
Oh, yeah, okay.
Whoop, whoop. All right, so circle that answer. What if they would have asked about children's tickets? Could we have found that? Yeah, let's look. You would look at the other axis, because see how this one's labeled C? You've got to pay attention to the labels. They asked for adult tickets, but C would be the children's tickets. So we would go up. Let's see. It's right here. So that looks about 425, yeah. So just pay attention to the labels. All right, let's go to the next one. I need to zoom out a little bit. All right, the system of equations D plus N equals 95. 0.10D plus 0.05 N equals 7.75. Can be used to determine the number of dimes D and nickels N in a child's piggy bank. Use the graph of the systems to determine which of the following is the best estimate for the number of each type of coin. So what is D and N? What do they stand for? Dimes and nickels. So dimes, number of dimes plus the number of nickels equals 95. So what does that mean? You have 95 coins, right, that were dimes and nickels combined. And then what about this? Why'd they put 0.10D? How much a dime is worth, right? 10 cents times dimes plus 5 cents times nickels equal, what does this 7.75 represent?
The total is
$7.75 in dollars, yeah. How much money he has. So we want to determine the best estimate for each type of coin now. All right, so let's make another point at the intersection. I'm going to zoom in so I can see it real good. Add a circle. And let's put it, that looks about right. Maybe over a little bit. I'm going to make it red. It looks about right. So let's estimate. So let's pay attention to our labels. So what is represented on the x-axis?
dimes.
Dimes, yeah. So right here, dimes. And then the y-axis is nickels. So how far does it go? 60? Looks like about 60 nickels. Okay, and then what about dimes? 35, yeah. So what's our answer? Yep, it's F. And one other thing that you could pay attention to is the dimes plus the nickels is supposed to equal 95. Look at it, the two bottom answer choices. 80 and 100? 180? Those aren't even on the right track at all. Oh, would it be G or F?
I thought it was G.
Okay, it's G, yeah. Good call. I was just looking at the numbers. Yeah, you got to pay attention to those labels. So 60 dimes, D, and then 35 nickels. Yep, they'll try to trick you that way. It almost got me. All right, so I'm going to circle G. All right, let's keep on rolling. I need y'all to find this slide. I think it might have been out of order. The slide that says writing systems of equations from word problems. Okay, so pull it up so it's on slide 16 for me. right, so let's look at the problems. We have 4 problems, and all we're going to do is define the variables and write the system. We are not going to solve it yet because I'm going to teach you another way of solving it, but not right now. So Valerie has a total of $3.15 in nickels and dimes in her pocket. She has 41 coins in all in her pocket. Write a system of equations that can be used to find how many of each type of coin Valerie has. So get a text box, and we need to define the variables. So the variables would be found at the end where it's asking what you're trying to find. So it says how many of each type of coin. So what are the 2 coins that we have? Okay, so we can use N is number, I'm going to use the little number sign of nickels. And then the other coin is dimes, the number of dimes. Now write our system of equations. So one of the equations will represent how many coins. The other one will represent how much money. Just like this last one. So look at the last one that we did. It says D plus N equals 95. So that's your number of dimes plus your number of nickels equals 95. So if we look over here, how many total coins do we have?
41.
41. So what is our first equation? N plus D equals 41. Uppercase, lowercase, it doesn't matter. Mine just, I guess caps lock was on or something. So that's equation 1. So equation 2, let's look at how they wrote that down for us. 10 cents D plus 5 cents N equals $7.75. So that's your money, how much money you have. So over here, let's see. How much is a nickel worth? 5 cents plus 10 cents times the dimes. How much total money does it say we have?
$3.15.
Yep, that's it. Okay, so that is our system of equations. We're not solving it yet. We're only writing equations today. Okay, I want you to do number 2. I'm going to pause it while you do number 2. Okay, so let's see how you did. Going to pull this over. Solid plus printed equals 480.
Oh, I'm on the wrong one. I was on number 3.
I guess I didn't define my variables yet. Okay, so S would represent solid color. And P is printed. And so number of, right, of rolls, that's what I should put. Number of rolls of, there we go. And then number of rolls of printed. So the first equation, S plus P equals 480, that represents how many rolls you have. So number of solid rolls plus the number of printed rolls equals 480. And then 4S plus 6P equals, that should say equals, right? 2,340. So $4 per solid roll plus $6 per printed roll. it's going to come up with the amount of 2,340.
Yeah.
Yep. All right. Good, good, good. Everybody got it?
Yep. Yes. I got the next one.
Okay, so I'm going to pause it again so you can do number 3. All right, so let's see how you did and compare it to mine. So C is the number of comedy movies rented. T is the number of thriller movies rented. Together, the movies will add up to be 10. So C plus T equals 10. And then the cost is 2 times C plus 3 times T
Equals 26.
equals 26. Yep. All right, I'm going to pause it again, let you do 4.